factors relating to subsea pipelines that must be considered in this investigation. Only the operators have the data about internal pressures and variations over time, and this is crucial to any investigation. So this investigation cannot be complete. Pipelines are resistant to compression from outside because of their shape. It is the same structure as an architectural arch or an egg that you cannot crush between two fingers at each end. In the case of a submarine pipeline, there is the strength of the steel plus the strength of the reinforced concrete weight coating. Pipelines are protected from corrosion by bracelet sacrificial anodes that dissolve to prevent the pipeline steel from dissolving. These are welded onto the pipeline at intervals and are not coated or weight coated. If these are depleted by accelerated corrosion, the pipeline steel will be dissolved until this area will not have the strength to withstand the internal pressure and the pipeline will burst. Pipelines are cleaned and products separated using pigs that are pushed along by pressure from the pumping station. If the inside of the pipeline has protrusions, the pig gets stuck and additional pressure is then applied. If this pressure is greater than the hoop stress yield of the pipe, it will burst at the weakest points. This is not necessarily at the location of the pig, but could be where a sacrificial anode, bracelet anode, has been depleted and the pipeline steel has been dissolved by accelerated stray current interference. These pictures show the sequence of these events. The internal pressure during normal operation hasn't affected this particular picture. The internal pressure during normal operation is shown by the red rings, which show the amount of pressure. The internal pressure during a pigging operation is exerting more stress to the weakened part of the steel under the neoprene coating that you can see in the picture. Internal pressure showing corroded epicenter. And then the next picture, the internal pressure showing corrosion weakening, extending, so gradually the steel is stretching. Additional pressure when the pig gets stuck. And then the final one is the pressure exceeds the yield strength and the gas pressure bursts the pipeline. This is shown by these circles that I've actually photoshopped onto here. This probability has been tested experimentally and the proof of concept confirmed. Here is a schematic of the experimental setup. We have the transformer rectifier, the instrumentations, and then the schematic of the layout of the experiment itself. There's a steel anode from which the charges are coming through the test piece with the steel pipe with the aluminium pressurised in the centre, and this is the copper cathode that I've inserted, and to prove the current flow, a steel nail here and a steel nail here, and this is the roving CPN half cell, which is the probe. Right, next picture. This is an actual photograph of the setup, and this is the Alexander cell here, and this is the steel anode, this is the test piece, and this is the CPN probe, two probes there. One is a fixed probe and this is a roving probe. The next picture shows the instrumentation and computer connections. This is a computer which is connected to the oscilloscope, which is there. These are recording voltmeters, and these are ammeters. This is the transformer rectifier, and this is part of the equipment where the connections are made through. If you scroll down, you can see the connections to the actual test bed itself, and this is the Alexander cell, the test piece, and the probes. This one, that's a fixed probe, and this one is the roving probe which will be moved along. Now we can see the results of the experiment, which is shown here, and the potential zones caused by the resistance of the electrolyte, which is impregnated into the cloth on which everything is standing, and measured through the roving CPN half cell, that specialised probe that we've designed. Now, to see the real results, this is what happened to that, which is a photograph, a real photograph. This is the result of the accelerated corrosion which burst the actual pressure vessel in here. Here is the pressure vessel, how we set it up. This is the current coming through here, into there, through here, out to there. And this shows the actual result. This has actually burst, and in the video you can see the bubbles come out and the actual here, the effect of the explosion. There are many hundreds more pictures with time-stamped, recorded, date as well as videos of the complete experiment, including the explosion of the capsule.